In this video, we are going to talk about stereoisomerism. Do you know what is the stereoisomerism? Stereoisomers have same chemical formula but different spatial arrangement. The arrangement of ligands in space is different, even though they are having same chemical formula. Such compounds are called as stereoisomers and the phenomenon is known as stereoisomerism. There are mainly two types of stereoisomerism, geometrical isomerism and optical isomerism. Geometrical isomerism is also known as cis-trans isomerism. It is mainly related with spatial arrangement of ligands around the central metal atom. Optical isomerism arises due to the way of rotating the plane polarized light. First of all, we can see geometrical isomerism in detail. Geometrical isomerism arises due to the ligands occupying different spatial arrangement around the central metal atom. It is commonly found in heteroleptic complexes, that is, complexes having different types of ligands. Complexes having different types of ligands present with coordination number 4 and 6. Geometrical isomerism is found in heteroleptic complexes with coordination number 4 and 6. Geometrical isomerism in complexes of coordination number 4. An example, mx2l2. It consists of a central metal atom M and two ligands X and L. X 2 in number, L 2 in number. So total of 4 ligands. Each ligands are unidentate ligands. Therefore, the coordination number of this central metal atom is 4. Coordination number is 4 and they are having square planar structure. They are having square planar structure. In square planar complexes, if the two ligands X arranged adjacent to each other is a cis isomer, and if X is in opposite to each other is a trans isomer. It is clearly written here. In this example, the central metal atom is platinum Pt. Ligands are NH3 ammonia and chloride ion Cl minus. When two X are adjacent to each other, when two NH3 is adjacent to each other, or when two Cl is adjacent to each other, it is the cis isomer, and when the same ligands are in opposite sides, it is the trans isomer. NH3 in opposite side or Cl in opposite side result in the trans isomer. So, mx2l2 where X and L are unidentate ligand and this mx2l2 is having square planar structure, it will show geometrical isomerism. That is, there will be difference in the arrangement of ligand in space around the central metal atom. If same group is adjacent to each other, it is cis isomer. If same group is opposite to each other, it form the trans isomer. Another square planar complex, general formula is MABXL. 4 different ligands. This type of a complex will show 3 isomers, 2 cis isomer and 1 trans isomer. The arrangement of it is given here. A, B adjacent to each other in the first one. In the second one also A, B is adjacent to each other, but the other two group changed its position. When we just rotate it, we will get this type of a configuration. Now again when we are rotating, we will get this type of a configuration where A and B is in opposite direction, L and X is in opposite direction. Based upon the priority order of the ligands, we are able to give a number for each ligands present, and by considering same number adjacent to each other, we can say it is cis isomer. That is, same prior ligands come adjacent to each other, it will be cis isomer. And if the less prior elements become opposite to each other, we can say it is the trans isomer. Now, geometrical isomerism in complexes of coordination number 6. That is octahedral complexes with the formula MX4L2 or MX4LA. Means 3 different ligands are there. They will show cis-trans isomerism if 2 L is adjacent to each other, it is cis, and if 2 L is opposite to each other, it is trans. In this example, you can see 2 ligands are there. One is ammonia NH3 and the second one is Cl2, Cl, chloride, that is 2 numbers Cl2. When this 2 Cl2 come very close to one another, it is cis isomer. When this Cl2 is opposite to one another, it is the trans isomer. In the case of MX4LA, we are able to say cis-trans isomerism. It is shown here. LA when come adjacent to each other, it is cis isomer. LA when opposite to each other, it is the trans isomer. Now, geometrical isomerism in complexes of coordination number 6. The third type of complex, MX3L3. In the beginning, we discussed MX4L2, MX4LA. Third type, MX3L3. They are showing a different type of isomerism, that is FAC and MER isomerism. FAC means facial. A set of similar ligands form one face of an octahedron if 3 donor atoms of same ligand occupy adjacent position of the corner of the octahedral face. It is FAC isomer. MER or meridian. When the positions are around the meridian of the octahedral, it will form MER isomer. You can see FAC and MER drawn here. Octahedron. One bond NH3, one bond NO2, then to the side, both sides are having 2 bonds. Here it is NH3, NH3, here it is NO2, NO2. When these three NH3 come very close to one another, that is, they are in the same phase of an octahedron, it is FAC isomer. When this NH3 is coming in the form of a Y, NH3 and NO2, you can see that it is in the form of a Y. This type of isomer is known as MER isomer. You can see how it is when we do separately. NO2 is in the form of a Y, NH3 is also in the form of a Y. When we mix these two, we will get this product, MER product. Now, optical isomerism. Optical isomers or enantiomers are pairs of molecules which make a plane polarized light equally, which will rotate a plane polarized light equally but in opposite direction. Optical isomers or enantiomers are pairs of molecules which rotate plane polarized light equally but in opposite direction is known as optical isomers or enantiomers. These isomers are non-superimposable mirror image of each other. We already studied optical isomerism in detail. I think you remember that optical isomers will be non-superimposable on its mirror image. And they are not having a plane of symmetry. That is, if we cut through a plane, if we are getting two half, we can say that material is having plane of symmetry. But in the case of optical isomerism, this compound is not showing plane of symmetry. Mainly two type of optical isomers are there, dextrorotatory and levorotatory. Dextro is represented by small letter D or plus sign. Levo is represented by small letter L and by minus sign. Dextrorotatory is the isomers which rotate the plane polarized light to the right side. Dextro will rotate the plane polarized light. When we pass the light through Nicol prism, it will get oriented only in one direction. When we are passing this plane polarized light through the coordination compound, if the compound can rotate the light towards right side, it is dextrorotatory. If the compound will rotate that symbol to the other side, that is left side, it is levorotatory. Equal amount of D and L isomers is called racemic mixture with a net zero rotation. It is commonly seen in octahedral complexes. You can see this example. Both are superimposable, means it is trans, which is optically inactive. Trans means same group on opposite side. This is a trans isomer and it is optically inactive. But this example will show optical isomerism because they are non-superimposable on its mirror image.